Hello, guys. Welcome back to another episode of Scrotitis Plays Feed the Beast. How you guys doing? We are hanging out here. It's nighttime in our little base area here. Don't have a good name for it yet, but check me out. I'm flying around because I got my jetpack made up. That's right, guys. We covered that, we covered how I was able to achieve that with the rubber farm here. I was able to actually collect enough rubber to go ahead and make the components for the jetpack. But what we did not cover last episode is the one thing that I promised that we would go over, and that is what we're going to do today. So if you guys aren't real big into the Computercraft and you aren't real big into the programs that you can write to make these things do some really cool stuff, then this is probably not going to be the episode for you. If you are, however, into Computercraft and you are interested in those types of programs and what you can do, you're going to want to sit tight because we're going over the program that I wrote to run in our tree farm, which is Extract. So, quick overview. It's been a while since I've done any type of Computercraft programming episodes. So, just for those of you who don't know, Computercraft uses the language LUA. It's a pretty simple language, and it has a lot of helpful APIs that really simplify what you need to do to write a program. Okay, so if you guys aren't familiar with programming, I suggest you go back and check out one of my earlier programming lessons because this is actually kind of an in-depth program, and I don't want to spend a lot of time going over the basics, but I have covered in episodes past the sort of layout and properties that you need for a Computercraft program. Now, I'm going to skip past these functions that you see, and we're just going to step through the program. Here we go. So here's the start of the program, and whenever we type extract and then hit the enter key, line, what line is it? Line 52 is where the turtle actually starts moving and processing, okay? So what happens is we have three variables that we're going to set. We have a tree count variable that we set to 5, a row count variable that we set to 2, and a tree variable that we set to tree count, or also 5. All right, and if you couldn't tell, based on the setup of our farm above, those variables are set based on the length and width of our tree farm. 1, 2, 3, 4, 5 is our tree count, and our row count is 1, 2. All right, so that's pretty straightforward, and that sort of lets you know that this program is going to be scalable, so that if you wanted to have this 10 trees long or 20 trees long, or if you like maybe the idea of having a square, well, I didn't account for spiders with my security wall apparently, but hey, get out of here. If you wanted to have a square tree farm, then you could have 5 rows and or 5 tree count and 5 rows, you know, however you wanted to work it out. The program allows for flexibility. I may not have coded all of that. I was a bit ambitious when I started the program, so let's just get through it and we'll see what we actually did. So actually the first line that we see here, line 51, 2 dashes indicates that you can put a comment into your code. That's basically only for the user, for the programmer himself, to leave a note for him so he's able to go back and see what exactly he did in a section. So I commented right here that that's the start of the program. Everything prior to that are functions that are going to get called as the program runs, okay? So we set our variables, we initialized our variables, and now we come down to line 56, and we have another comment that says, come out of starting position, okay? So what we have here is our turtle's starting position, right here next to our charging station, which if I haven't talked about, well, I know for a fact I spoke about in the last episode, and prior to that I didn't know that they existed. This thing is awesome. I love it. So this is the starting position for the turtle. It's also the ending position, oddly enough. All right, so to come out of the starting position, we have the turtle going up. Whoa. That was loud. Hey, there's no rain sound. That's weird. Huh. Anyway, rain sounds annoying, so I'm not upset about it. But the first thing we have the turtle do is go up 3 times, turn to the left, go forward, and turn to the right. And all that's doing is it comes up out of the hole, turns to the left, goes forward, turns to the right. So it ends up right here facing that block right there in its starting position, ready to begin extraction, okay? The next thing that we do is we start our loop process, and this is the real meat of the program, okay? Now this is saying while tree is greater than 0, so we set tree to 5, that's how many trees we have in one row. While that is greater than 0, we want to do the function tap 1 tree, and then we want to do the function find tree, and then we want to subtract 1 from that number. So we're basically saying while 5 is greater than 0, do this function, and then make tree 4, and then it loops. While 4 is greater than 0, do this one, and then 3 greater than 0, do this one, 2 greater. So you get the idea. At the end of the row, tree variable will be set to 0. 0 is not greater than 0, so then it'll stop looping. Okay. Before we get down to the turning that we have programmed here, let's go take a look at tap 1 tree. Okay, and that is going to be this function right here, and this actually has a bunch of function calls within it. Now, that's why this is one of the reasons why I said this is a bit of an advanced program that I wrote, because it has nested function calls. If you wrote the code out line by line without using these functions, it would probably be close to, well, it would easily be probably 500 lines of code. And that would be extremely unwieldy and very difficult to debug if there was a problem. And if you guys are familiar with the Computercraft programming, it's not the best interface to work with, and so it's pretty easy to accidentally type something wrong. So if you were dealing with 500 lines of code and you had a typo on line 362, it wouldn't be very fun to debug and try to find that error, would it? Excuse me. All right. So function tree 1 or tap 1 tree. What this does, it says these are the function names that I wrote: ext face up, top reposition, ext face down, bottom reposition, and then repeat ext face up, top reposition, and ext face down. Now I tried to give these names that sort of explained what they did. Basically what this is saying is extract face up. So I want to extract everything from the face that's looking at me as I move up the tree. And then the next line is going to be a top reposition. So this means we've gotten to the very top of the tree. We need to reposition so that we can then go down, which is the next function. We're going to extract everything as we go down. And then bottom reposition is going to be a function that's going to move us around to the next face so that we can go up, back to the top of the tree, and then down. All right, so let's go ahead and look and see what these functions are doing. All right. And I think that takes us, right back up to line 1. So the first one that we wrote is extract face up, or ext face up. And all this is doing is a loop that says, while there's something in front of me, I want you to dig, and then I want you to move up. Now, the one thing about dig, which is kind of cool, and look at all. This is what I wanted to try and show. It's not really. Let me try it down here. Turtle. And this isn't even all of them. This is just a handful of the turtles. I wonder. Tree. Let's see, it doesn't show up here. You can make tons and tons. I don't even know the mass number of turtles that are available in this game. We made a TreeTapTurtle. Now, the Lua language, the turtle API that's available doesn't have an extract or a tap function. So whatever item your turtle is equipped with, whether it is a sword, a pickaxe, a shovel, an axe, and in our case a tree tap, the turtle.dig command is basically your clicking action for the turtle. Okay? So what this is saying is, while there's something in front of me, I want you to dig. I want you to click. I want you to say, hey, if there's something there, if your tree is there rubber in there? Okay, if there is, it's going to extract it and store it in its first storage slot. And then it's going to move up. And it's going to go all the way up until it doesn't detect anything in front of itself. So it's going to go to the very top of the tree, where even above the leaves. Okay? The next function was top reposition. And that's this function right here. So we're going to get to the very top of the tree. We're going to move forward 1 block. We're going to turn to the left, and then we're going to move back. I actually had it beforehand going forward, turning left, or turning right, then going forward, then turning right 2 more times. And I thought to myself, well, wouldn't it be easier if we just turned the opposite way and went backwards 1 block? Because we'd be facing the side of the tree that we needed to extract from then. So that's what I rewrote this to. Forward, tree left, and back. And then the next function that's called is extract face down. It's basically the exact same as, well, it's not exactly the same, because we're not detecting in front of us anymore. We're detecting below us, okay? And what we're saying is, well, another difference is turtle detect. If you return a true, you don't have to have equal sign for a while or a comparative equals. So you see how I have while parentheses turtle.detect do. That means while this is true, do it. But for the turtle.detect down, if it's true, it's not going to be able to go down. And we don't want it to go down. So what we want to do is we want to set this equal to false and say, once you reach the bottom, the ground level, then stop. So we have to have the comparative equal to the 2 equal signs. While turtle.detect down is false, meaning that there's not something below it. I want you to dig the block that's in front of you. I want you to check, since this is a tree tap, I want you to try to extract rubber from the block in front of you, and then I want you to move down 1. Pretty simple. And then once we get to the bottom of the tree, we call the bottom reposition function, which is going to say turn to the right, go forward, turn to the left, go forward, and turn to the left. So basically, we're just moving counterclockwise around the tree. Okay? And then I believe we call the turtle up, the top tree reposition, and turtle down again, right? I think that's the whole... Yeah. For tree tap 1. I skipped 1, didn't I? Yeah. Okay. So we've extracted from all 4 faces of the tree now. What do we need to do? Well, we need to find the next tree. Pretty logical, right? So we have a function called findTree. Okay? And it's pretty simple. It's, what is it, about 9 lines of code, 8 lines of code? So what this is going to do, this is going to make the turtle, it's going to be facing the tree, and we basically need to find the next tree. So we're going to turn left, we're going to move forward, we're going to turn right, we're going to move forward, we're going to turn left. And we're going to say, while turtle.detect is false, go forward. Okay, so this again is going to allow you to vary the size and layout of your rubber tree farm. If you want to have your trees spaced 5 blocks apart, this will allow for that difference. Okay, this is going to say keep going forward until you find that next tree. The first 5 lines are just repositioning you in a line that should put you directly facing the next tree. And then the while loop that we have is telling it just to keep going forward until you run into whatever's there. Okay, if it's a tree, or if it is a wall, or a mob, whatever. That is one thing that this program doesn't account for while moving, is if it would run into a mob. Our design up top is actually pretty safe. It's pretty mob-proof with all the lighting and just the one entry point. But depending on your layout, you may want to account for mobs in your code. And that's actually something that I believe we included in our query program that we did at the beginning of this season of Feed the Beast. So check that out if you want to see what to do about encountering mobs. Okay? So let's see. Not there yet. This is a part that we yeah. So I didn't account for the multiple rows. Sorry, guys. If you want to see that, I can go ahead and rewrite this. But for the time being, I'm just going to leave it the way it is because it works perfectly for my design of the tree farm. So basically what's happened is we've gone to the end. Here, let me show you what's happened so far. We've come out of the hole. We've gone up this side. We've come down this side, up this side, down this side. We've turned left, gone forward, turn right, turn right, gone forward, turn left. And then we've gone forward until we ran into the next tree. We've repeated that process all the way down to the end, and we've gone forward until we can't go forward anymore because we have a wall here. Okay? Now, we could write a process that detects this block and compares it to a rubber tree block, probably in slot number 16, which is what I was gonna do. Compare what the block that's in front of you to have one of these in the inventory of the turtle, and then if it's different, then turn right. Like do something where you turn this way, compare here, no, compare here, no, compare here, yes, and then go to it. But I just did a simple. Okay, we're not there anymore. I know the way my farm's laid out. Just turn left, go forward 3 blocks, and turn left again. Okay? Then we reset our tree variable to tree count because we know it's 5. 1, 2, 3, 4, 5. So we reset it to 5, and we just do our loop again. So we're going to go around all 4 sides of each of these trees, and we're going to end up right in this position. Okay? Let's check out the code real quick just to verify that that's what I wrote. Yeah, so we're at the end of the line. Turn left, forward, forward, forward 3 times, and then turn left again. We're resetting our tree variable to the tree count, which we set at the beginning, and then it's the same exact loop that we did before. If we figured out a way to account for our turning at the end of our rows, we could actually encapsulate these 2 loops inside of a loop that used row count. I believe it's up here, right? Yeah. We could have a program that uses this variable for our master looping because we want to know how many rows there are. But since I just went with the size of rubber tree farm that we did, I wrote the program like this. And I may change this if we expand our rubber tree farm, and if so, maybe obviously won't cover in detail the program, but maybe we'll do like a paste bin or something so you guys can see the differences. But anyway, here real quick. Now we need to come back down off the platform. We need to deposit our rubber, and we need to go back to the starting position, okay? So what we do here is really simple. We're dropping off our rubber. So we're facing that last tree. We're going to turn right, go forward, and then we're going to be over top of the hole over here. That's going to place us right up there over top of the hole. What we then need to do is go down to, we're going to select what's in this first item, and since there's nothing in here, whatever's in there, we're going to drop it down. And that's going to fall right into this area. We've got our redstone engine, which is powering the obsidian pipe, which should suck up anything within this radius, right like this. So it should catch anything that falls down from there. All right. And then we need to return to the charging and starting position. And to do that, all we do is actually when the turtle comes down, it's going to be right at that block facing this way. So all we do is we say, we do a for loop, and we say for I equal to 1, do this 5 times and increment in steps of 1. All right, this is a for loop, and this is the syntax for it. Another way of writing turtle back, to make the turtle move backwards 5 blocks would be right turtle.back parentheses, turtle.back parentheses, turtle.back parentheses, turtle.back parentheses, turtle.back parentheses. Whew. But an easier way to do it, if you exceed 3 actions, 3 repeated actions of the same type, it's much easier to do a for loop, and it's going to save you tons of time. And you just need to understand the syntax, which is pretty easy. You just have to remember that it's a for loop, and then this variable isn't actually used down below. Well, if you're clearing your inventory, it's used. Different cases you use it. For just moving backwards, forwards, whatever direction, it's not used. And it's really simple. Again, we want to set I equal to 1. We're telling it we want to do whatever actions down here 5 times. Or we want I to stop at 5, and we want to get to 5 in steps of 1. So it's going to say I equals 1, go back. I equals 2, is it 5? No, go back. I equals 3, is it 5? No, go back. 4, is that 5? No, go back. 5, is that 5? Yes. Stop, exit loop. We're going to turn right, and I believe that's the end of the program, line 96. Okay. So actually, that's closer to 1,000 lines of code if you think about it, guys. Those 5 functions that we have written in there would basically need to be repeated for each tree that we have up there. So 96 lines. Well, technically, the functions take up 50. So we'll call it, I think I was probably close, probably a little over 500 lines of code as opposed to 96 with the way this was written. And we could probably minimize it a little bit more if we wrote a function to do the turning around at the end of the line. So I'm going to go ahead and Control exit. All right, guys. So, hey, that's going to do it for this episode. I wanted to go over the code. We saw it run last episode. So if you missed it, go ahead and check that out. Episode 11, Turtle Tree Tap Rubber Farm. Say that 3 times fast. That's a tongue twister. But that's going to do it for us this episode, guys. I want to thank you all for watching. And once again, thank you all for the continued support. You guys are great. Without all the support you guys have been given, I wouldn't still be doing this. So, again, I want to thank you all. This has been Scrotitus Plays Feed the Beast, and I will check everybody all in the next episode. We will see ya. Bye.